Hello students, hope you are doing well. In this video, we are going to look into the next concept of properties of matters and fluids, that is fluid dynamics. The topics that we are going to discuss under this concept are equation of continuity, Bernoulli's equation, Torricelli's law, Venturi meter and dynamic lift. So let's start with equation of continuity. Now what does equation of continuity mean? So for a steady flow, or in fact for a flow to be steady, the volume of fluid entering a point should be equal to volume of the fluid leaving a tube. Only in that case what will happen is the flow would be steady, otherwise the flow would be unsteady. So rate of flow, or we say rate of flow. What is rate of flow? Rate of flow is the amount of fluid or volume of fluid flowing through a unit cross section is called rate of flow. Rate of flow is constant. So I can say equation of continuity can be generalized by saying that rate of flow is constant through any tube. So if rate of flow is constant, what is rate of flow? Area, volume of flow flowing through a fluid. So let me take this part. You can see that this part is 1 and this part is 1. So what is volume of flow? Volume of fluid flowing. So volume of fluid flowing entering, I'll call this as 1, this is 2. Volume entering at 1 equal to, I can write it as volume is delta x1 into A1. This is volume. This is volume of the fluid, that is at point 1. And what is volume at point 2? It is equal to delta x2 into A2. This is volume. Now what is rate of flow? Rate of flow can be written as amount of flow flowing per unit time. So I can say this is V1 by T and this should be V2 by T. Because rate of flow is constant, I'll get V1 by T equal to V2 by T. Again, don't get confused, this V is volume. So what is V1 by T? I can write delta x1 into A1 by T should be equal to delta x2 into A2 by T. Now delta x1 by T can be considered to be velocity at the first cross section and delta x2 by T can be considered as velocity of the second cross section. From these two, what do we get? We get V1 A1 equal to V2 A2. This is what is equation of continuity. So this implies that the mass rate or volume rate of flow through any pipe of any cross section of a streamline flow or a steady flow of a fluid is always constant. The next concept that we are looking into is Bernoulli's theorem. Bernoulli's theorem states that for any incompressible non-viscous fluid in steady state, the sum of the pressure at any part, the kinetic energy per unit volume and the potential energy per unit volume always remains constant. So it is basically conservation of energy in another form. In order to explain this, let me take 2 points on the path of a fluid or liquid. This is point 1 and this is point 2. Now what is total energy at point 1? I can say half mv1 square, this is kinetic energy, plus mgh, this is potential energy, plus pressure P1 into V, volume, that is pressure energy. Now this should be equal to half mv2 square, that is kinetic energy, plus mgh2 plus P2 into V. What I'll do is I'll divide everything with volume. When I divide everything by volume, I'll get m by v v1 square plus m by v gh plus P1 equal to half m by v v2 square plus m by v gh2 plus P2. So m by v is density, so that can be written as half rho v1 square plus rho g h1, this is h1, plus P1 equal to half rho v2 square plus rho g h2 plus P2, or I can say half rho v1 square plus rho g h1 plus P1 equal to constant. So when it's a constant, I don't have to have the suffixes 1 and 2. I can directly write it as half rho v square plus rho g h plus P equal to constant, right? So the sum of kinetic energy per unit volume, potential energy per unit volume and pressure energy per unit volume is constant. So now let's look at this. So when we have half rho V1 square plus rho G H plus P equal to constant, that means if 2 points are at same height, let me take H1 equal to H2, then what will I get? I'll get half rho V1 square uh, plus P1 equal to half rho V2 square plus P2, or I can write P1 minus P2 equal to how much? Half rho into V2 square minus V1 square. In this way I can find the pressure difference. Now the second thing, if the velocity of flow is constant, under what condition velocity of the flow would be constant? If the area of cross section of the pipe is same. So if velocity of the flow is constant, that is V1 equal to V2, in that case what will happen? I'll get rho G H1 plus P1 equal to rho G H2 plus P2, or I can write P1 minus P2 equal to rho G into H2 minus H1. Similarly, if heights are constant, I mean of course we have taken heights to be constant. If pressure is same, then half rho V1 square plus, then kinetic energy, change in kinetic energy would be equal to change in potential energy. So depending on the given situation, we can use any of the expressions that we have seen now. Now one of the applications of Bernoulli's theorem is Torricelli's law. Now what does Torricelli's law state? So let's apply Bernoulli's theorem for this particular expression. Of course here it is shown as closed, but if this should be open, then this part will have atmospheric pressure, this also will have atmospheric pressure. Now let's say the difference in heights, I'll take this height as h1, this total height as h2. So difference in height delta h can be written as h1 minus h2. And let's say velocity at this part is v2 and velocity at this part is v1. Now applying Bernoulli's theorem, I can write P1 plus half rho V1 square plus rho G H1 should be equal to P2 plus half rho V2 square plus rho G H2. I'm sorry. So from this, what all things we know? We know P1 equal to P2 equal to atmospheric pressure. So those can be cancelled. Now what am I left with? I am left with half rho V1 square plus rho G H1 equal to half rho VT square plus rho G H2. Now we know A1 V1 equal to A2 V2. Now here we see that A2 is very much greater than A1. Now that would imply V1 is very much, so V1 is very much greater than V2, or V2 is very much less than V1. So I can neglect this component V2, half rho V2 square. So what will that give me? That will give me half rho V1 square equal to rho G into H2 minus H1. So I'll cancel rho, I'll get V1 equal to 2G root 2G into H2 minus H1. Now this is equivalent to the expression of a freely falling body. So this is what is called Torricelli's law. So if I want to put Torricelli's law in words, I can say the speed of Flex, that is the speed with which water comes out of a small hole in a tank. I'll say speed of Flex is equal to the speed attained by a freely falling body, is equal to the speed attained by a freely falling body dropped from the same height, dropped from a height equal to height of the fluid column. So height equal to height of fluid column. So this is what is Torricelli's law. So I don't have to keep on deriving this expression. I can directly write V equal to root 2GH. The next thing that we look into is a venturimeter. A venturimeter is a device which is used to measure the speed, rate of flow of a liquid. Now how does it work? It's a tube of non-uniform cross section. We have a constriction between 2 points. Now because if I take points 1 and 2, you see that points 1 and 2 are at the same height, so I don't have to consider heights. So by application of Bernoulli's equation, I can write half into rho into V1 square plus P1 equal to half into rho into V2 square plus P2. So from this what will I get? I'll get P1 minus P2 equal to half into rho into V2 square minus V1 square. This is what we are getting. Now this one I'll take, generally we have mercury here, so that the height is not very high. So P1 minus P2 can be written as rho Hg into G into H1, delta H, which is the difference in heights of the vertical columns. I'll keep it as delta H, which is given as H. So that can be written as rho Hg into G into H. I'm sorry, this is small h. So substituting this, we'll get rho Hg into G into H equal to half rho into V2 square minus V1 square. Now other thing that we know is A1 V1 equal to A2 V2. We'll substitute this in that particular equation. So let's go to the next slide to do that. So we have rho Hg into G into H equal to half rho into V2 square minus V1 square. So A1 V1 equal to A2 V2. This is what we have. From this I can write V2 equal to A1 V1 by A2. So let me substitute it here. That would imply rho Hg into G into H equal to half rho into V2 square. Instead of V2 square, we'll write A1 square V1 square minus this also becomes A2 minus A2 square V1 square by A2 square. So from this I can take out V1 square outside. So that will give me rho Hg into Gh into A2 square. We have a 2 also by A1 square minus A2 square. So V1 equal to A2 into square root of course there is a rho also, square root of 2 into rho Hg into Gh into by rho into A1 square minus A2 square. So this is what is V1. Now rate of flow would be A1 V1 again. So rate of flow is denoted by this, volume flowing per unit time is equal to A1 V1. So that will be equal to A1 A2 under root of 2 density of the fluid, I'll take it as rho 2, density of the fluid in the pipes, vertical pipes, into acceleration due to gravity into difference in heights in the vertical pipes by density of the fluid into A1 square minus A2 square. If both the densities are same, it becomes 2gh by A1 square minus A2 square. So this is how we measure rate of flow through a venturimeter. Now after this we have other phenomena of dynamic lift. Now dynamic lift is the phenomena of a lift being created due to the pressure difference. Now how does pressure difference, how is a pressure difference created in case of dynamic lift? Let me take an example of a spinning ball. You can see that there is a ball spinning. Now if you look at the upper point, you see that wind is flowing at a higher speed. So if at the upper point you can see that this is how wind is moving, and here the wind is, the relative velocity of wind with respect to the ball is slow. So if relative velocity of wind with respect to ball is slow, then the pressure, I'll say this is P1 and this is P2. At P2 with respect to ball, V2, I'll say velocity here is V2 with respect to the ball and V1 is here. So we can see that because the ball has to cover this much distance and the relative velocity from the center is V1 plus V2 because it is rotating in the same direction, I can say V2 is greater than V1. If velocity is greater, then what will happen? Pressure will be less. So P2 is less than P1. So the point above the ball is at less pressure than point below the ball. As a result of that, what will happen? The body will go up. So if I want to find what is the effective lift, I can say effective lift equal to lift force is equal to P1 minus P2 into area. So P1 minus P2 can be written as half rho into V2 square minus V1 square into area. The same principle is used in aeroplanes. In aeroplanes, the wing of the aeroplane is designed something like this. So when the wing moves with the plane, the air which is going from above has to cover greater distance than the air which is going from below relative to wind. So relative to the wing of the plane, if V1 is the velocity below of the air velocity below the wing and V2 is the air velocity above the wing, then V1 would be less than V2. That would imply P1 is greater than P2. So because there is a high pressure below the wing and low pressure above the wing, the wing and as well as the plane would lift up. In this way, the upward force acting on the plane, helps it in lifting as well as keeping it from falling when it is flying. So this is what is there in fluid dynamics. What all things we have seen? We have seen equation of continuity. Then we have seen what is Bernoulli's equation. We saw that Bernoulli's equation is nothing but the conservation of energy principle put in a different form. Then we have seen application of Bernoulli's principle in Torricelli's law, or the velocity, in calculating the velocity with which a fluid comes out of a small orifice in a container. And then we try to understand how venturimeter works, and finally we tried to see what is dynamic lift and how a lift force is created due to the pressure difference created as a result of the difference in velocities of the wind with respect to the object above and below it. So this is what is there in this particular topic. Hope you could follow everything that we did. Thank you very much for watching this video and also watching other videos on Get My Classes. Make the maximum use of this to get a very good score in a competitive examination. Thank you once again for using Get My Classes.